Okay, so let's solve this problem we have here, which is integral from 0 to 1 of x e to the x squared dx. Now, you see in math, sometimes there are different methods we can follow to solve a problem. This problem can be solved by two different methods. For example, we can solve it by parts, by doing integration by parts, or we can solve it by substitution. In this case, the easiest way to solve this would be by substitution, but if you try to solve it by parts, you should end up with the exact same solution. So let's do substitution here. In this case, the idea of substitution is to look for the inner function. What do I mean with inner function? The inner function is that you will find inside another function. Right, so in this case we have the function e, which is a power function, right? So in this case the inner function would be x squared. This is what is inside the e function. So in this case we can say that u, or we can state that u is going to be equal to x squared. Okay, so next, the idea of solving by substitution is to find the derivative of u, the u we just found. So in this case, the derivative of u would be 2x d dx. Now, there is a trick to substitution that will help you most of the time, if not all the time, where we need to solve this equation we just got here for d dx. So so we get dx equals du divided by 2x. Okay, so in this case we have two important equations, which are u equals x squared. So let's put it yellow here. So, and dx equals du divided by 2x. Okay, these are the two important things here. Now, in substitution, we have two options. We can either work directly with these two and substitute, or we can also substitute the limits of integration. The advantage we have when substituting the limits of integration too is that we will just need to solve the integral directly after we just have taken the integral of u. So there is no need to do an additional substitution. So that saves us a lot of time. But you can solve the indefinite integral and then substitute u back, and you will end up with the same answer. In this case, we are going to substitute the limits of integration too. Remember that in a general integral, the lower limit will be called a and the upper limit will be called b. So in this case, we have that a equals, we will take the u equation we just got and substitute x with the lower limit, which is 0. So in this case, it will be 0 squared, which equals just 0. So it will be the same. And let's find b2. In this case, b equals, again, we substitute 1 in for x, so we get 1 squared, which turns out to be just 1 as well. Okay, so these are the other two important equations we will need when doing our substitution. Okay, so let's mark them yellow. Okay, so now it's time to do the substitution. The idea of substitution is to change the values or the expressions we have inside our integral for the equations we have here. For example, we know that u equals x squared, so this means that this x squared we have here, this x squared we have here, will be changed for a u. d of x, or dx, or the derivative of x, will be equal to du divided by 2x. So this dx we have here can be changed for du divided by 2x. And you'll see why this works later. This 0 should be changed for a 0. Since they are the same, it just remains the same. And this 1 should be changed for this one we have here. So it remains the same as well. Okay, so this is our integral. This is the integral we need to solve. But in order to solve this integral, we need to have only used to it. I'm sorry. We only need used to it, right? So we need to get rid of this x. Since these x's I'm going to are being divided, since these x's are being divided, we can get rid of them. So we get the following integral. Integral from 0 to 1, of e to the u, e to the u divided by 2 du. So that's the integral we need to solve. Now, there is a rule of integration that tells us that whenever we have a constant in our integral, we can take that constant out. Since we are dividing e to the u, we can take these 2 out. So we end up with 1/2 multiplied by the integral from 0 to 1 of e to the u du. Right? So that will be the integral we need to solve. So let's copy this integral here. Let's solve it. Okay, now this is a standard integral, right? We know that the integral of e to the u will be the exact same thing. So the integral of e to the u is e to the u. This is why this function is such an important function, or a special function, we can say. So we end up with the following. So we end up with the answer 1/2. Let's write the 1/2 out here of e to the u, and we are going to evaluate it from 0 to 1. From 0 to 1. So in order to evaluate it, we just need to substitute 1 into u and subtract it when substituting 0 to u. So we end up with 1/2 multiplied by e to the 1 minus e to the 0, and that will be it. So we just need to do this subtraction, right? So we end up with 1/2 multiplied by e to the 1 minus 1. Remember that any number when raised to the power of 0 will be equal to 1. And this will be our answer. If we need to, or if you need to get the answer as a decimal number, we can also calculate that. We just take our calculator and find out that this is going to be 0.859. This is an approximated solution. This is the exact answer, and this is an approximated solution. So I hope this helps. Don't forget to follow me on my channel. And if you ever need some tutoring, I will be happy to work with you. You can just click on the link below in the description, and hope to see you soon.